Hi guys, you welcome to my channel. Today we want to start the revision part for physics, and this class is majorly meant for the Jamb Waec and the Waec student. The essence of this revision is to allow you to quickly recap all the whole thing you should know about each of the topic that we are going to be looking into. So today we are starting with revision of measurement and unit. If you want the full lecture of this particular topic, that is where I treated the topic itself, you can check the description part of this video to access the link to the video for you to learn more. Now let's get started. When you talk about measurement and unit, it's an important topic in physics, and the questions on that it's usually been within number 1 to number 10 in most cases. So what do you need to know about this topic? Number 1, you have to understand the fundamental quantities and the derived quantities. When you talk about the fundamental quantities, we have the mass, we have length, we have time, we have temperature, we have current. Mass, length, time, temperature, current. We have magnetic flux, and we have luminous intensity. All these are the fundamental quantities. Now when you talk about these fundamental quantities, majorly, if the question says what are the 3 fundamental quantities in physics, the 3 fundamental quantities in physics include the mass, the length, and the time. And that's the reason why you always see that anything called dimensions, they are always written in form of MLT, because mass, length, and time, they are the major fundamental quantity that we have in science. Now that we understand the fundamental quantities, when you now talk about measurement, what exactly are we measuring? Remember, the derived quantities are those quantities that are formed by the combination of fundamental quantities. That is, derived quantities include speed. And when you talk about speed, speed is the same thing as saying length, what you can refer to as distance, divided by time. You see that I combine length and time together with division to get speed, and that's what we call fundamental quantities. That simply derived quantities rather. That simply means that for me to know derived quantities, then I need to measure these 2 fundamental quantities. And that brought us to what exactly I want to explain that makes me to mention all these quantities, which is measurement. So when you talk about measurement, you have to talk about measuring instruments. But before you talk about the measuring instrument, you have to know the quantity you are actually measuring. So what quantity do we measure? We majorly measure the fundamental quantities. And when you talk about the fundamental quantities that we measured, basically we talk about mass, length, and time. So without wasting time, let's look at the instrument used in measuring mass. Now when you talk about the instruments that we use in measuring mass, mass can be viewed in 2 ways. People view mass as mass, and they can also view it as weight. So oftentimes, students usually mix these 2 up, but they are not the same thing. This one is the quantity of matter present in the body, that is, mass is the quantity of matter present in the body, while weight is the gravitational earth pull on a body. This mass is constant while this weight varies, because weight is mass times gravity. So gravity varies from place to place, but mass is constant. So if you take a mass from this earth surface and you take it to the planet, the mass is going to remain the same. But when you take weight of a body from here to the earth surface, the value is going to change. Why? Because gravity changes. Now, oftentimes, examiner always want to mix you up here by giving you some instrument, and they will ask you which of these 2 can we use this to measure. So when you talk about mass, Mass can be measured using chemical balance. chemical balance what you can call the beam balance, or you use what we refer to as lever balance. These are the two instruments that we use in measuring mass. Now, sometimes, before I go into that sometimes, let's look at the instrument used in measuring weight. To measure weight, we make use of spring balance. I hope you get this. Now, examiner will always want to ask you, in some cases, they want to ask you if you actually understand the principle that all these instruments based on. So, and that's why questions usually come to test. Whenever question comes to test if you understand the instrument used in measuring this, those questions usually come up with testing if you understand their working principle as well. So what do I mean by the working principle? When you talk about the lever balance or the chemical balance, they work based on the principle of movement. You have to know this. They work based on the principle of movement. Why? When it comes to spring balance, it obeys Hooke's law. Do you understand this now? So these are basic things that you should know between mass and unit. That is, when you talk about the instruments used in measuring mass and weight, you have to understand that mass is always constant and is measured in kilogram. So anytime you are given mass and it's not in kilogram, you are advised to convert it to kilogram. Why this one is measured in Newton? These are things you should have at the back of your mind. Now, lever balance, chemical balance, we use them to measure mass directly. Why? They obey the principle of movement. And for weight, we use spring balance, and that obeys the Hooke's law. I hope you get this clear. Cool. Now that you understand this, let's go to the next quantity, which is length. Now, when you talk about the length of an object, for us to measure length of an object, we have the following measuring instrument. We have what we refer to as meter rule. We have meter rule. We have vernier caliper, or let me make it like this so that it's gonna look neat. You can easily jot it down. And I expect you as a student watching this to have a note for my channel, because I'm yet to cover the entire aspect of what you need to do well in your Jamb. So let's see. When you talk about length, that is instruments used in measuring length, we have meter rule. We have vernier caliper, and we have micrometer, screw gauge. You see, these three instruments, we use them to measure anything called length. However, I want you to understand something about this instrument. What exactly do examiner want to test you on these three instruments? Examiner want to test if you understand the numbers of decimal that you need to report the results. That is, if you measure something with meter rule, what numbers of decimal do you need to report your answer? If you measure something with vernier caliper, what number of decimal do you need to report your answer? If you measure something with micrometer screw gauge, what numbers of decimal do you need to report your answer? That's number one thing they want to know there. So for meter rule measures to 2 decimal places in centimeter. That is, if you have this thing in centimeter, it measures to 2 decimal places. If you have it in millimeter, you have it to measure to 1 decimal place. I hope you understand this now. 1 decimal places in centimeter, 2 decimal places in 2 decimal places in centimeter rather, and 1 decimal places in millimeter. So 1 decimal places in millimeter. I hope you understand this. This thing seems insignificant, but these are things they test you on. For example, examiner can tell you that which of the following reading cannot be achieved using meter rule. So I can give you 2.0 centimeter. I can give you 2.05 centimeter. I can give you 2.005 centimeter. So you should know this is going to be the right answer. However, if these things are in millimeter, 2.0 millimeter, 2.05 millimeter, 2.005 millimeter. Then this is going to be the right answer. So these are things that examiners want to test you on, and you have to understand them in order for you to be able to handle them successfully. I hope you understand this now. So we are done with that of meter rule when it comes to number of decimal places. What about vernier caliper? For vernier caliper also measures to 2 decimal places in centimeter. So when you have it in centimeter, it measures to 2 decimal places. I hope you understand this now. In centimeter, it measures to 2 decimal places. And in millimeter, just like you have it under meter rule, it also measures to 1 decimal place in millimeter. But for micrometer screw gauge measures to 3 decimal places in centimeter and 2 decimal places in millimeter. Do you understand this now? So examiner can ask you that which of the following instrument measures to 3 decimal places in centimeter. These are questions that have been asked. So I hope you understand it now. So second thing you should understand about these quantities is just that the reading accuracy. So when you talk about the reading accuracy of an instrument, what it simply means is that the least possible error that you can make. And when you talk about the least possible error you can make, the error is between this. Let's say you have a meter rule, and that meter rule, you have all these small line, you have 10 of it, and then you have big ones. So this is 1 centimeter, you count another 10, then you have 2 centimeter. When you now talk about the reading accuracy of this particular two, the reading accuracy is basically between this small line, between one small line and the other. I don't know if you understand what I'm saying, because if you're going to be confused of what the actual reading should be, is when your reading fall between these two. I hope you understand that now. And that's why measuring accuracy, or what you can refer to as reading accuracy, is going to be divided by 2. This one is 1 millimeter, right? So 1 millimeter, 10 millimeter make 1 centimeter, right? So your reading accuracy is going to be 1 millimeter divided by 2. The smallest graduation here is 1 millimeter. I hope you understand. Then the reading accuracy is going to be the smallest graduation divided by 2. So that simply means that for meter rule, the smallest graduation is 1 millimeter. Then the reading accuracy for meter rule is going to be 0.5 millimeter or is 0.05 centimeter. And this is where we get the number of decimal places in which they measure. This is where we get it from. So I've explained that in the actual video. If you think you need to watch it, then you can check the description part of this video to get that. Also, when you talk about that of the vernier caliper, for vernier caliper, the reading accuracy, because vernier caliper is like 10 times more accurate compared to meter rule. Are you getting? So because it's 10 times more accurate, the reading accuracy is given as 0.1 millimeter or 0.01 centimeter. And you can easily note this whenever you are calculating under vernier caliper. So, and for micrometer screw gauge, you have it to be 0.01 millimeter or you have it to be 0.001 centimeter. You see reason why it measures to 3 decimal places in centimeter and why it measures to 2 decimal places in millimeter. Likewise others. So that's that. That's the next thing that you need to understand. So the next thing that you now need to understand when you are working with all these instruments is what they use them to measure. What exactly are they using them to measure? So basically, these are the 3 things that examiner wants to ask you under this particular measuring instrument, that is instrument used in measuring length. So for meter rule, we use it to measure long length. This one is used to measure long length. So it can be tape rule, it can be meter rule, what have you. So when they talk about instruments used in measuring long length, you talk about the meter rule. Then for the vernier caliper, vernier caliper is used to measure the internal and external diameter of a round object. The internal and external external diameter of a round object. That's what they use the vernier caliper for. Why? When you talk about the micrometer screw gauge, the micrometer screw gauge is used to measure the external diameter of a round object. This one is used to measure external diameter of a round object. Why? It can also be used to measure the thickness, of a thin wire. So this is what we use micrometer screw gauge to measure. We use it to measure the thickness of a thin wire. We use it to measure external diameter of round object. Why? Vernier caliper is used to measure both internal and external diameter of a round object. And meter rule is to measure a long length. So basically, this is what examiner wants to ask you under the instrument used in measuring length. Now, sometimes examiner can now decide to make it a bit technical for you. What do I mean by making it a bit technical? Is that examiner can ask you that what are the instruments used in measuring area? So area is a derived quantity. Am I making sense? Area is a derived quantity because it is length times length. That is length square, right? So if you are going to do this, we use instruments such as measuration. We use measuration to calculate area, or we use graph to calculate area. So, and when they talk about volume also, volume is length cube. Are you getting where I'm coming from now? So, we can also make use of measuration. So, when I say measuration, I'm talking about mathematical formula. Are you getting this now? Or you make use of measuring cylinder. So, examiner can ask you that what is going to be the instrument used in measuring the volume of irregular body. So, you should know that it's going to be what? A measuring cylinder. Though there are some other things that are other form of explanation that you should understand there. But basically, that is what they want to understand about the instrument used in measuring length. So, the next thing he wants to know now is the instrument used in measuring time. So, when you talk about the instruments used in measuring time, we have a couple of them. We have stopwatch. We have the stopwatch. We have the ticker timer. Ticker timer. We have ticker timer. We have what is it called? Hourglass. We have hourglass. We have the water clock, pendulum, and so on like that. So all of that are instruments used in measuring time. And sometimes they might want you to look into an equations that has to do with time, though it's not really expected under for Jamb Waec or for Waec students. But for sake of knowing sake, just know that the period of oscillation of a simple pendulum is given as T, which is the time to count the numbers of oscillation divided by the numbers of oscillation, and you can have it as 2 pi the square root of L over G, where L is the length of the probably the wire or the thread that you are using for your pendulum. Basically, the length of the pendulum. Let me put it like that, and your small t can be written as 2 pi n then the square root of L over G. So we'll talk more about this under simple harmonic motion, but just for a basic understanding is the reason why I mentioned this. I hope this is clear now. Now that we are done with the instruments used in measuring all of this, now let me talk about the instruments used in measuring temperature. Of course, we all know that the instrument used in measuring temperature is thermometer. And when you talk about electric current, we use what? Ammeter to measure electric current. So, but basically, you might not want to go into those ones because those ones are being considered under another topic. So, basically, these three quantities are what we really need to focus on. I hope you understand this now. So, another thing we now need to understand under this topic is how to understand the fundamental quantities and the derived quantity, which I've mentioned earlier, but we now need to consider their units, because unit plays an important role when it comes to physics. So when you talk about the unit of measurement, for mass, we have the unit of measurement to be kilogram. That's a fundamental unit. And for time, we have it to be second. Then for length, we have it to be meter. For current, we have it to be ampere. For amount of substance, which is also a fundamental quantity, amount of substance, we have it to be mole. For temperature, we have it to be Kelvin. For magnetic flux, we have it to be Weber. For luminous intensity, we have it to be candela. So CD, WB, K, MOL, capital A, small m, and second S, and this is what? kg. So sometimes in questions they can ask you that which of the following is a fundamental unit. So they might put it as kg, seconds, and what? M. So this usually being like part of the options, and this is going to be the right answer to your question, or kgms, anyhow they arrange it. But just know that these are the fundamental quantity. Now, fundamental unit rather. So we now have what we refer to as derived unit. Derived unit is just like derived quantity, whereby they are formed by the combinations of the fundamental units, just like their quantity are formed by the combination of fundamental quantity. And we have numerous numbers of derived quantity, but we have very limited number of fundamental. So when I talk about what the derived quantities, we have speed and velocity to be measured in meter per seconds. We have acceleration to be measured in meter per second square. We have momentum to be measured in Newton seconds. And you know, Newton, that is force. Force is measured in Newton, and 1 Newton is equivalent to kilogram meter per second square. So, and this one can be kilogram meter per seconds for momentum or impulse. Are you getting where I'm coming from? And the list goes on like that for derived units. Now that you've understand this, now not all scientists agree with the whole of the derived units. Am I making sense now? But as long as you can prove them that they actually exist, or they have some relationship with the fundamental quantity, then it can be accepted. Are you getting it? And that takes us to the last part of the video, which is dimension of a physical quantity. Dimension of a physical quantity. Now, when you talk about this dimension of a physical quantity, how should you go about it? What is it, sir? Dimension of a physical quantity is a method of you trying to establish relationship, or to confirm the relationship between a derived quantity and a fundamental quantity, by expressing the formula of a derived quantity all in fundamental. What do I mean? Let's take for instance that you are given this quantity, force, and you are asked to look for the dimension of this force. How should you go about it? Just follow this step. Number one is for you to know the formula for force. And what's that formula? Mass times acceleration. That's the formula for force. The second step is to express this formula as a fundamental. That's the second step. That is, force is equal to mass is already a fundamental quantity. So we write it down as m. Let me write it as small letter m. Then multiply by acceleration. Acceleration is velocity all over time. So we've seen another fundamental quantity, which is time, but we can still break it further because this second step is to make everything fundamental quantity, right? So you can have that F is equal to mass all over time multiplied by velocity. So instead of writing down velocity, we can write it as F equal to mass over time multiplied by, what's velocity itself? Velocity is displacement over time. And since displacement, distance, altitude, height, they are just length, alright? I can just write it as L all over what? Time. And this will going to give us ml all over t squared. So that's a second step complete. You know, we have expressed everything in terms of fundamental quantity now. So the third step that you need to take now is to replace all these fundamental quantities. Mass, anywhere you see mass, replace it with capital letter M. Anywhere you see length, replace it with capital letter L. Anywhere you see time, replace it with capital letter T. So that makes you have F equal ml over t squared, right? So what's the last step? Because examiner wants you to express this thing as an exponential. And that's why you will see them giving you some question like m to the power of x, l to the power of y, t to the power of z. And they will ask you to be looking for the value of x, y, and z that will make that dimension correct. Am I making sense now? So that's the reason why your last step is for you to write this thing in an exponential form. So this is the same thing as saying capital M, capital L, of course, the all raised to power of 1, and this thing, when you have a number coming from the denominator, right? That is, if I have maybe 1 over x, it's the same thing as saying x raised to power minus 1. Of course, you know that from indices, and if you don't, you can check the channel. We have lecture on indices there so that you can understand why this is like this. And if I have 1 over x squared, this same thing as saying x raised to power minus 2. For that reason, if I have this to be 1 over t squared, so this is going to be capital T raised to power minus 2. So if you look at this now, then you are good to go. Am I making sense? So this is going to be the dimension for force, ml t raised to power minus 2. However, as a Jamb Waec, there is a trick I want you to understand. If you can know the unit of all this quantity, getting their dimension will be very fast for you. Remember, you have just 1 minute to answer questions, right? But for Waec students, you have to go through these particular steps. But for Jamb Waec, why can't you just do like this? Since you know that force is kilogram meter per second square, so you already know that kilogram is the unit for mass, replace it with capital M. Meter is the unit for length, replace it with capital L. And seconds is the unit for time, replace it with what? Capital T. And then you have the dimension very fast, under how many minutes? Jiffy. Do you understand that now? So that's that. You have to learn how to what? Solve smart. Now, I wouldn't like to leave you just like that. That's all about the topic that you need to understand. But I don't just want to leave you like that. I would like us to look at some questions under what we just finished discussing now. So let's look at the very first question here, and I want you to pay attention to all these questions. They might seem simple, but what I want to do by solving them with you is to point out how examiner wants to confuse you, even when you know what you want to do. I hope you understand that. So now let's look at this. So when you look at this question here, you get to see that, okay, I'm coming. All right, so let's look at these questions together, and we can solve them together as well. Now, this is the first question here. The question states that in order to remove the error of parallax when taking measurement with a meter rule, the eye should be focused. Now, what is error due to parallax? That's the first thing you need to understand. Error due to parallax is when you are trying to, I discussed this in the main video, so you can check it out. When you are trying to measure something and you are looking at it slantly, when you look at it slantly, something that is in between will seems like is on a particular number. Are you getting it? Why? Because you are looking at it slantly. So for you to correct parallax error, you have to look at that particular measurement. Mostly it usually happen with all these instruments that utilize this ruler form of a thing, like an ammeter, like your stopwatch, your meter rule, and so on like that. So how should you solve this? What you have to do to prevent parallax error is to look at it directly, and the right option there is going to be option C. That is, look at it vertically downwards on the markings. Are you getting it? So error due to parallax can be prevented when horizontal level are observed horizontally and vertical levels are observed vertically. So there's nothing like horizontal levels here, right? So you have to look at it vertically downwards on the marking. I hope you understand this now. So that's how to go about what the parallax error obtained. So the correct answer to this question is option C. So let's look at another question here. Which of the following represents the correct precision? Which of the following represents the correct precision of the length of wire? Okay, if the length of wire is measured with a meter rule. So you see what I just explained to you previously. So which of the following represent the correct precision if the length of wire is measured with a meter rule? So remember, I told you this question is Jamb question 1986. The previous one we solved is Jamb question 2012. So this one is 1986. Now, remember I told you about measuring accuracy of all these instruments, and whenever you are measuring using meter rule, you have to measure in 1 decimal places in millimeter, isn't it? So the correct answer to this question is option B. I hope you understand this now. So these are minor things that a couple of teachers and students always like overlook when they are doing all of these topics. They really count a lot. I hope you understand this now. All right, so let's move to the next question. So the next question states that one of the following readings represents the measurement of the length of a metal rod using vernier caliper. Taking the reading accuracy into consideration, the most likely one is, so the question you should ask yourself, if you look at all these questions now, they are basically about their reading accuracy, right? So what you should ask yourself is that vernier caliper measure to how many decimal places in centimeter? Of course, 2 decimal places. So anyone that is in 2 decimal place is going to be the right answer. And that's option what? Option A. I hope somebody is getting this clearly now. So let's move to the next question. So all these are very, very simple, but if you don't understand all these things, you tend to find them difficult. And that's why the only thing you can do for yourself to arm yourself is to overlook that this thing is small when it comes to you preparing for Jamb or Waec objective. It's very, very important. So which of the following can be used to measure accurately to 3 decimal places in centimeter? So I want you to pause the video and tell me if you get it right in the comment section. So in 3 decimal places in centimeter, that's what? Micrometer, screw gauge. And that's option D. Very, very simple. It becomes so simple when you know what to do, guys. So let's move to the next question. And the next question states that which is the least possible error in using a rule graduated in centimeter? Okay, so this is quite tricky. And why is it tricky is because most times all these rules, you might not understand what they mean by a rule graduated in centimeter. So you might want to mistake it for a rule graduated in millimeter. So when a rule is graduated in centimeter, that simply means that the smallest unit on that particular rule is 1 centimeter. If it is graduated in millimeter, the smallest the smallest graduation on such a rule is going to be 1 millimeter. And for you to know the least possible error, you just divide what? The least graduated unit divided by what? By 2. So the graduated unit is in centimeter, right? So that means you have to say 1 centimeter divided by 2. So 1 centimeter divided by 2 is going to give you what? Is 0.5 centimeter. Do you understand that now? Normally, meter rule, when you have a meter rule that you have something like this, 1 centimeter, there are other small 10, you have 2 centimeter. If you have this, what this simply means is that this thing is graduated in millimeter. Am I making sense? So the least possible error here is going to be 1 millimeter because the least value here is 1 millimeter. 1 millimeter divided by 2, and that will be 0.5 millimeter. So if you are given the options in centimeter, then that means you have to convert this one you have to convert it to centimeter, right? That will be 0.1 divided by 2, and that will give you 0.05 centimeter. But if they say if the question states that is graduated in centimeter, that means all these small values, they are in centimeter, right? So 1 centimeter divided by 2, you get the error, which is 0.5 centimeter, and the correct answer there is B. Do you understand that now? I hope it's clear. All right, so if it is clear, please don't forget to engage with this video by you dropping your comments. If it makes sense, if you want more of this, just let us know what you learn, if it is helping. And don't forget to like, subscribe, and share with your friends. Very, very important, please. It will help this channel to keep growing, and when we keep growing, the energy to keep creating will be there. Thank you guys for all you have been doing. So the next question here states that Roman figure 1, diameter of a small ball bearing. Roman figure 2, thickness of a piece of wire. Roman figure 3, diameter of a measuring cylinder. Roman figure 4, length of a piece of wire. Which of the above can be measured using micrometer screw gauge? So you see now that the question is basically about testing what they are using all these instruments to measure. So when you look at it, you ask yourself, micrometer screw gauge is used to measure what? The thickness of a thin wire, and also the external diameter of a round object, isn't it? So let's look into that. We have thickness of what? Of a piece of wire. So this one is going to be part of it. Roman figure 2. Any option that has Roman figure 2 is going to be the right answer. So I can eliminate, and this is how to answer this kind of a question. You see, anyone that does not have Roman figure 2, it means it can't be the answer. So option D can never be the answer. Am I right? So we are left with A, B, C now. Okay, so which other one? Diameter of a small ball bearing. Diameter of a small ball bearing. Diameter of a small ball bearing. That means a ball bearing only have external diameter. A ball bearing is what they call bodies. Are you getting it now? It's like a melter ball, small melter ball is what they call ball bearing. So it only has external diameter, isn't it? So that means this have to be part of it, right? Because micrometer screw gauge is used to measure external diameter of a round object and the thickness of a piece of wire. So a piece of paper is as thin as a piece of wire, Abi. So that means 1 and 2 is part of the answer. Now, diameter of a measuring cylinder. A measuring cylinder has internal diameter and external diameter. So let me show you what I'm saying. If this is a measuring cylinder, sorry, don't mind my drawing, just for your understanding's sake. So if this is a measuring cylinder, from here to this place is internal. So the diameter from this place to this place is internal diameter. Why? From this external part here to this external part here is external diameter. So if the question is diameter of a measuring cylinder, you don't know if they are talking about the internal or the external. So automatically, this cannot be part of it because micrometer screw gauge is not used in measuring internal diameter. Length of a piece of wire, of course, you should know that that's meter rule. So this is not going to be part of it. So any option that has Roman figure 3, Roman figure 4 in it should be out. This one is out, and this one is also out. So the correct answer there is B. I hope you understand how I was able to analyze those questions for you, because I don't just want to pick the answer for picking sake. There's still more for you to learn. Is that taken out? Now, the next question says, the inner diameter of a small test tube can be measured accurately using, so inner diameter of a small test tube, inner diameter. So I want you to let me know, do you get it right in the comment section? So that's going to be pair of a vernier caliper, because micrometer screw gauge is for external diameter, meter rule is for length. I have 2 micrometer screw gauge here. That might probably be error from my own part while I'm typing the question. So that's just basically it. So the correct answer is going to be B, which is, I think this option here probably is going to be microscope, because yeah, it's going to be microscope the way I'm looking at it. So however, the correct answer, or if it is what I'm thinking, then anyhow, the correct answer to this is going to be a pair of this pair of dividers. Sorry, no, the inner diameter of a small test tube can be measured accurately using vernier caliper. It's supposed to be a vernier caliper. So that means I must have missed either this or this should have been a vernier caliper. So please just note that that will be error from my own part, maybe while I'm typing the question. So however, let's move to the next one. I hope you understand that. So okay, which of the following is not a fundamental SI unit? So when you say fundamental SI unit, is the same thing as fundamental unit. Am I making sense? So meter rule is a fundamental unit, ampere is a fundamental unit, Kelvin is a fundamental unit, second is a fundamental unit. This one is looking weak, and that's what that's going to be the right answer. So radian is not a fundamental unit. I hope you understand that. So that's too cheap. Huh? So the next one is, which of the following is a derived unit? So we have kilogram, meter, Kelvin. These three are fundamental. So the derived unit here is going to be Newton, which is the unit for force. And the next question here, we have the international agreed system of units. That's the same thing as saying what? Fundamental units. I hope you are getting this. For physical measurements are LB, it simply means pound, FT is feet, and S is second. So this is not fundamental. Gram, meter, and seconds, these two are fundamental, but gram is not fundamental, so B cannot be the answer. Kilogram, meter, and seconds, correct. This is the right answer. So the correct answer here is option C. Are we together? So let's move to the next question. And the next question states that, which of the following statements are true about the spring balance and the chemical balance? Roman figure 1, both are used to measure the mass of an object. Is that true? No, because spring balance is used to measure weight, while chemical balance or beam balance is used to measure what? Mass. So option, anyone that has Roman figure 1 cannot be the answer. So automatically, option D cannot be the part of it. Option A cannot be part of it. Okay, so we are left with B and C. Are you seeing the way I'm answering all these questions now? So you have to be technical and be smart in answering your questions. So I've eliminated the options now. So let's go to the second one. Either of them may be used to measure the weight of an object. Obviously, no. So anyone that has Roman figure 2 cannot be the answer either. So B cannot be the answer. So I don't even need to read the remaining one. C is going to be the correct answer. I hope you understand this. And when you look at it, Roman figure 3, the spring balance works on the principle of Hooke's law. That's correct. We talk about that. Why the chemical balance works on the principle of movement. Correct. And Roman figure 4, a change in gravity changes the reading of a spring balance, but not that of chemical balance. Of course, I told you that. I said mass is constant, weight varies. So weight varies because of the change in gravity. So I think I summarized this topic well. Guys, you have to kill Jamb this time around. I'm happy to be showing you all of this. Now, when you look at this next question, the next question here states what? The question states that, which of the followings are the correct SI unit of the quantities indicated? So we have N, which is Newton for force, and we have Newton per meter, which is torque. We have watt for power. We have kilogram meter per second square. So what's the question? Which of the following are correct SI unit of the quantities indicated? I'm having issue here. I think I skip one thing while typing these questions, and that's kilogram meter per second square. I don't know what is it for. God, shit. Okay, I think what I should be having here is momentum. Yeah, I remember. This is 1988, question number 2, 1988. So this momentum. Now let's see. Newton, this is correct. So any option that has Roman figure 1 is going to be correct. Anyone that doesn't have Roman figure 1 will not be correct. So everything has Roman figure 1, right? So we cannot eliminate. Then Newton per meter for torque. What is torque? Torque is moment. Moment of a copy is what they call torque. And when you say moment, moment is force multiplied by the perpendicular distance. Abi? So that is Newton meter, not Newton per meter. So anyone that has Roman figure 2 will not be correct. Option A is not correct. Option B is not correct. So we are left with option C and D, right? Okay, watt, that is power. So anyone with Roman figure 3 is going to be correct, right? Okay, so they both have Roman figure 3, so we cannot eliminate here. Kilogram meter per second square. This is for force. Remember, we derived that initially because force is mass times acceleration, right? So mass is kilogram and acceleration is meter per second square. So this is for force. Momentum is kilogram meter per second. I think I showed you that, right? So automatically the right answer to this is going to be option D. I hope you understand this breakdown. So if you do, let's move on to the next question here. And what's the next question, guys? So the next question is, which of the following quantities has the same unit as the watt? Oh, this is kind of technical and you have to be good mathematically. So when you say watt, it is what? The unit for force, right? Or for power rather. So what's power? Power is equal to work done all over time. Abi? So work done is given as force times distance, right? Divided by time. And I can rewrite this equation as saying that power is force multiplied by distance over time. And this distance here, according to the options, you can take it as what? Displacement. Am I making sense? And this is going to be F multiplied by velocity. So force times velocity is the same thing as what? Power. And that's option D. I hope you understand this. Cool. So if you do, that's going to be the right answer. Now let's move on to the next question. And that's this next question here says the physical quantity that has the same dimension as impulse is A, energy, B, momentum, C, surface tension, and D, pressure. Oh, I can easily know that if I know the definition of impulse. Impulse is the change in momentum. That is, if momentum is mv, impulse is mv minus mu. So the correct answer is going to be B. I hope you understand this. All right, so let's move to the next question. And the next question states that, which is the last part of the video, which of the following is the dimension of pressure? So how do you get dimension? Very easy. So you can just say, what's the formula for pressure for Jamb Waec? That's Newton per meter square. Because pressure is force over area, right? And that's Newton divided by meter square. So what's Newton? Newton is kilogram meter per second square, right? Then multiply by meter square, isn't it? So this is going to be per meter square rather. So this is going to be kilogram per meter per second square. So if you replace kilogram with capital M, you have this. Capital L, you have this, and capital T, you have this. So which one have this as part of the option? Option A is the right answer. Now, however, if you don't know all these units, if you want to solve it normal, this is how to go about it. Pressure is going to be force all over area. Force over area is going to be pressure equal to, so break everything down to what? Fundamental. That's mass times acceleration divided by area, which is going to be length times breadth. Abi? Now, we already have this one to be fundamental, and this one also is fundamental because breadth is the same thing as length. So I can just say m all over L square multiplied by acceleration. I'll kind of do a cheat here. And what's that cheat? Is that, okay, for YX students, you might not do it. Let me just break it down. So this will be velocity over time, right? So that means I'm having pressure to be mass all over L squared T multiplied by velocity, right? So velocity is what? Displacement, which is length all over time. Abi? So this is going to be M. L, we cancel one of these L here. So I'm going to be having M divided by LT squared. And that will just be ml raised to power minus 1 t raised to power minus 2. I hope somebody get this right. So that's the right answer to the question. So I've shown you the shortcut and the proper way of solving it. I hope you guys practice and solve more questions on this. So do well to watch the entire video. So I explain a lot of things, how to calculate for vernier caliper, micrometer, screw gauge. So do well to watch them. The next question says that the dimension of viscosity are, oh, this is cool because I'm very sure a lot of you, you're not familiar with the formula for viscosity. Am I right? All right. However, I got you. This question is Jamb question 2008, question number 1. So, what's how are we going to go about it? Viscosity. All right. So let's see. For viscosity, I have that. I'll just write down the formula directly. This is force times distance divided by the average velocity, area times velocity rather, and this is going to be mass times acceleration, times distance divided by area multiplied by what, velocity. Am I right? So this is going to be mass, capital M, and acceleration is lt raised to power minus 2 multiplied by capital L divided by L square multiplied by velocity is lt raised to power minus 1, right? We don't need to be showing that again because you already know that. So we have been using it since. So viscosity is going to be, this one will cancel this. Then we have okay, I think this one will also cancel this. So we have capital M K divided by L t raised to power minus 1, right? Okay, so if this should be the case right now, this is going to be M t raised to power minus 2 plus 1. Then this is going to be L raised to power minus 1 from indices, and our result is going to be capital M L raised to power minus 1 and T raised to power minus 1. So where is it? Option B is the right answer to this. So I hope you understand this. If you don't, let me know in the comment section. All right. So the next question here is going to be this. At what respective values of X, Y, and Z will the units of force, the Newton, be dimensionally equivalent to this? Of course, I've done the derivation before, right? So let me just skip time. So this will be ml t raised to power minus 2. This is this dimension for force, right? So let's compare it with this. M to the power of x, L to the power of y, and t to the power of z. So if you equate the two, you have this to be raised to power minus 1, raised to power 1, and raised to power this. So this is going to be mx, L to the power of y, and t to the power of z. So this m will cancel m, so x is equivalent to 1, and this will cancel this, y is also equivalent to 1, and this will cancel this, and z is equivalent to minus 2. So your right answer is going to be 1, 1, minus 2. 1, 1, minus 2. That's option B. I hope you understand this now. So that's how to get that. And the last but not the least, thank you so much for watching to this time around, and I'm wishing you success in your Jamb exam. So this is the last question, so that we call it today and we move to the next topic on the syllabus. The values of x, y, and z respectively in the expression m to the power of x, L to the power of y, t to the power of z for the universal gravitational constant G are. So what's the universal gravitational constant G? So we have that F is equal to Gm1 m2 divided by r square, which is the distance square, right? Okay, so make G the summation of the formula. So we have G equal to Fr square divided by m square, because this is mass, so let's just write it as m square. So what's the dimension for force? Force is capital ML t raised to power minus 2, then multiply by r is distance, that's, let's make it L square divided by m square. So this will cancel one of these, right? And this is going to be L cubed. So I have that G is going to be L cubed t raised to power minus 2 divided by m. So you can rewrite this one as m to the power of minus 1, L to the power of 3, and t to the power of minus 2. So if this is what I have, I can just compare it with this. So if you compare it with m to the power of x, L to the power of y, and t to the power of z, you get to see that x is equal to -1, and y is equal to 3, and z is equal to -2. So which one is -1, 3, and -2? -1, 3, and -2. So the correct answer is option B. Thank you so much for watching to this time. And do well to share this video with your friends. Subscribe to this channel if you have not subscribed, and please give us a feedback. The more you comment on this video, the more YouTube is going to suggest this to other Jambites that really need to what success, that really need success in their forthcoming exam. Till tomorrow, that I'm going to give you another topic under the same syllabus. We are taking the syllabus one after the other, so get the summary of the next one tomorrow. See you guys.